All right. Today, here's what we're going to cover. I want to make sure that you guys understand the basic forms of what you had in your homework yesterday. The one that I want to make sure, we're going to go through division one more time. Make sure you understand a couple division problems. I have a couple picked out from your homework in tint. You might want to write them down. The next one we have to cover is I want to make sure that you understand if they're doing something on the bottom where they're adding a couple things together, like a couple radicals. They're called binomials. We're going to do a binomial or two if we need it. The last one we'll cover is if they put a weird fraction in a power. Those are the last two problems that you have. I want to make sure you get to see multiple ways of doing that. We're going to go about 20 minutes worth of notes here, and you have 20 minutes to just kind of work and ask questions, and you can move around. Obviously, you're probably sitting where you want, but you can move around still because obviously you can sit kind of where you need to. Okay, questions on what we're doing today? Perfect. All right, let's jump right in. First one I'd like you to write down. 8x. Something like this. I think this is one of your problems you had. Okay? Or it was something like insanely close to it. Alright, this is a division problem. Here's how I would do this problem to begin with. Now, I saw some people yesterday, they were trying to figure out what to multiply by. I'll walk through that process here in a minute. I would say the easiest way to do this problem is just divide it. Because does everyone recognize that 72 is actually divisible by 8? Like, you can divide those. And what about x cubed over x? Do you see that I can actually divide that? When you actually divide those, there's no more fraction anymore. Because it literally will cancel out the entire bottom. So what is 72 divided by 8? 9. X cubed divided by x?
X squared.
X squared. Now, you can just take the square root of that. And that's your answer. So what is the square root of 9?
3x.
What's the square root of x squared? X. Done. There's your answer. Some people didn't recognize the ease of how you could do that. Holy cow. Okay, now, if you didn't recognize it at first, because I don't mind that you tried it a different method. But what you need to be able to do is if you had that problem, 72 x to the third over 8x. Some people just want to do their normal math that they're taught in Algebra 2, where you just multiply by whatever's on the bottom. And I'm totally fine with that. Some people were doing that yesterday. They're like, well, since it's a square root, you can always just multiply by the square root of 8x. Right, top and bottom. That's what Algebra 2 taught you. Whatever's on the bottom, multiply by it. It'll always make a perfect square. It will get you to the same answer in the long run anyway. Because the bottom will simplify, because the bottom's going to turn out to be the square root of 64x squared. The top is going to be a really big number. It's going to be x to the fourth. 8 times 72 is a 6 carry a 1. 166 or something like that. 72 times 8. Oh, 576. Jeez, what am I doing? I don't know what I just did for 7 times 8. Alright, anyway. So whatever you get there, so that's just multiplying straight across. This simplifies to be 8x, because that's the square root of 64x squared. The top, 576, is a perfect square. It's a perfect square. It's 24. That's the square root of 576, and x to the fourth, the square root of it is x squared. Like, if you didn't know that, you could break it down and see pairs. You eventually get this. Those still divide up and down, and guess what? Still makes that. 24x squared divided by 8x is still 3x. Huh? Okay, questions on the different methods. Now, the reason why I bring this up is number one, some people didn't see the simplicity that you can divide if you want to, because I said you can simplify first. But the other thing that I brought this up for is because the way that I was doing these yesterday, I think was confusing some people. Because how I do this is completely different than anyone else. Because what I do, if I can't divide these right away, I would break up 8x into all the factors of 8, break up 72 into all the factors of 72, and then I try to figure out what is the minimum thing I need to multiply on the bottom to get rid of the square root off the bottom. That's very different than what you're taught in Algebra 2. I understand that. But I wanted to reinforce, some people have this idea in their head. You're doing correct math, I just do mine a little bit differently. All right, questions on the two ways of doing that? I think this is probably the easiest way, if you can recognize you can divide that. By far, it's the simplest form. All right, questions on that first problem. I believe that was one of your questions. I think that was like number 28 or 29 or something like that. 28. Okay, all right, let's move on. I want to go to the next problem now. The next one that we have.
I think we just go through the whole homework.
No. All right, the next one. I think it was something like this. I need to look at the book. So we have a book.
My dad has that shirt for. Mine does too.
That's right.
Is it right? I was trying to go off of pure memory.
Yeah, that's right.
All right, never mind. Thank you for that. I was right. That was pure memory trying to pull that off. All right. Okay. This problem. What number is it, by the way?
73.
73. Okay, so number 73. The reason I bring this one up is the same as the one we just did. If you recognize it, do you agree that these are the same type of radical? Just divide them. So if I divide these, 64 divided by 2, that's 32. And x to the 6th divided by x is x to the 5th. Because you can cancel them out. You can literally divide these before you start. Now at this point, you can just take the 5th root of these, because if you didn't recognize it, 32 is a 5th root. 32 is a bunch of 2's being multiplied together. It's actually 5 2's multiplied together. The x to the 5th is 5 x's. And the idea is that this is still under the radical house. So what you're looking for is groups of 5's. I have a group of 5, I have a group of 5. You can kick them out of the house, and there's your answer, because there's going to be nothing left in the house. The answer is just 2x. That's how you take a 5th root of something. You're looking for groups of 5's. Well, I had a group of 5, I had a group of 5 of 2's, and a group of x's. So I can kick those out. One goes out, the rest of them cancel out. Questions at all about number 72? Now, if you didn't like this, you could try to figure out what to multiply in the bottom to make groups of 5's. I just think it was easier if you divide it to begin with. Some people didn't recognize that. I had a lot of people asking questions yesterday about that in the afternoon. Questions? Okay, the next one I'm going to write down on the board, I believe is not a homework problem. It needs to be somewhere in your notes for sure. 100% you need to know this problem.
This next one?
This next one I'm going to put.
Okay.
Wait, no, what number was that?
That was 72. All right, here we go.
He's going to do 72.
All right, this is not a T, this is a plus sign. So, what you're looking at here is a rational expression. It's irrational because it's a fraction. But the weird thing is, on the bottom of this problem, this is unique, I didn't talk about these yesterday. The bottom, this is a binomial. Now, if you don't know what a binomial is, it's two items being added or subtracted together that you can't actually simplify. Do you agree that I can't add a 4 plus a square root of 2?
Yeah.
Like, they're not even the same thing, I can't add them together. Unless I figure out the decimals and try to assume that I could add them. But the idea here is I want to get rid of this square root off the bottom.
Isn't it just multiply by 4 minus?
Exactly. So the trick is you multiply by what they call the conjugate. The conjugate is taking the bottom and doing almost the exact opposite. It's not a perfect opposite. It's 4 minus the square root of 2. You probably recognize doing that from Algebra 2 class.
But I just didn't know how to do it.
Yeah, so this is called a conjugate. So it's the opposite sign in the middle. Now, why we do this? Why are we multiplying that to the top and bottom? It will cancel out all the radicals on the bottom if you do this correctly. Shh. So what I'm going to do is I'm going to distribute the top. I'm going to FOIL the bottom. FOIL means first, outer, inner, last. If you can remember that from, your days of doing it from Algebra 1 or Algebra 2. So the top. If I multiply the top together and I FOIL it together, distribute the top, this root 3 will be multiplied on each part here on the top. So the top is going to turn out to be this, 4 root 3, because I can't actually multiply those together, they just sit side by side, minus the square root of 6, because you can actually multiply root 3 times root 2. Does that make sense when I get on the top?
Yes.
On the bottom, you have to FOIL, first, outer, inner, last. I think the easiest way of thinking about FOIL is you're just distributing twice. You're taking the 4 right here and you're distributing it to the back, everything back here, writing those down. Once you've done that, then you distribute the root 2 to everything in the back. So you're just distributing twice. That's first, outer, inner, last. It covers it as long as you think it's just distribution twice. So, here we go. I'll try to color code. 4 times 4, 16. 4 times a negative root 2, that's negative 4 root 2. So that's the first 4 times everything in the back. Now, color coding, root 2 times everything back here. Root 2 times 4 is 4 root 2. And root 2 times a negative root 2 is a negative square root of 4. Because I can actually multiply root 2 times root 2. Now, why you do this? Why I actually multiplied by conjugate? If you can see it now, it will cancel certain terms out. Right? You can probably recognize that. The middle terms here, one's positive, one's negative. These literally will cancel each other out because they'll add to make 0. And the square root of 4 in the back, this is just a nice number. This is just the number 2. Right? The square root of 4 is 2. So what happened here is you have no radicals left on the bottom. So what my answer actually is, so far, it's 4 root 3 minus root 6. And on the bottom, I have the 16 minus 2. Well, 16 minus 2, what is that, 14? There's your answer. Like, I would accept that as your answer. The back of the book will probably go further. I like that answer, the better answer. Does everyone understand how I got to those parts? I didn't talk about any of those yesterday. I was saving it for today to make sure that you understand what we're doing, because it takes more time than what I had yesterday. Are we somewhat comfortable with the whole conjugate rule? I'll do another one if you need. Please. Negative exponents? Oh, yeah, where you move stuff around. Let's see. Which one? Okay, that negative, actually move up. So give me that problem here in a second. Okay. All right. So hey, Jade, I'm going to ask for that one here in a second. All right. Hey, are we good with that first problem, or I guess third problem?
Looks so good.
Yeah.
Okay. All right, Jade, fire away. I want that problem that you're working on right there.
The square root of 500x to the third
Okay.
over
Square root 500x to the third.
over the square root of 10x to the negative first.
Okay. It's obviously this is one of your homework problems. What I would do on this problem, I would divide these, and with the negative exponent, I would move this x up top, because it's telling you it's on the wrong side of the fraction bar. So really, to start with, what's 500 divided by 10? 50. 500 divided by 10 is 50. And then since the x moved up to the top, there's 4 x's up there. Now you can go ahead and simplify from there. There's no fraction anymore. So this made the problem a lot easier to look at, and now I can simplify from there. Does that make sense, Jaden?
Yeah.
Okay.
So where do you go?
All right.
from there?
Last,
Is that the answer?
you simplify it, break it down, and you kick them.
Oh.
All right. Last problem today, and then I'm going to give you a ton of time where you can just work on your homework. We have to deal with it when they give you powers that are fractions. So there's one problem in particular where they did something like this.
It's not. Well, you're wrong. Didn't work.
I didn't know.
You were doing something.
Then you do X.
Then there's 5. Oh, yeah.
I weighed like 24.
Oh, shit.
Just waiting people out. All right. We haven't talked about fractions yet. This is something that deals with radicals. You may have seen them in Algebra 2, where they talk about fractions, but the problem is, I don't think you've ever had to go this level, where you had to like multiply things together and understand what it's actually saying. I'm going to show you my shortcut for doing this, which I think works every single time. But I want to show you the real math that's behind the scenes. Okay, so what this actually is saying is it's like a law of exponent problem we did like a couple days ago. Like when we did problems like this, 4x squared times 7x to the third power y. Like when you multiply things together, you actually multiply the numbers up front, and everything else just gets tacked in the back, and you just add up all the letters in the back, right? That's what we're doing. The problem is we have fractions. So we're doing it by the same method. You're adding up all the variables in the back, but the number up front is actually being multiplied. So in this problem, I'll actually multiply the 2 times 5. So what I'm going to get is 10. For the x's, you have to add the powers together. So somehow, I have to figure out how to add not a full x, I have to add like a fraction for an x. So I have 3/4 plus 2/3 of an x. It's not quite a full x. So what do we have to do? Same denominator. Because when you add fractions, this is something you did back in general math days, you had to add fractions, you have to get the same denominator, so I have to make these both 12s. The common number that 4 and 3 both go into, it's common multiple. Okay? And so, if I'm going to make these both 12s, this one I had to multiply by 3, so I take the top times 3, I get 9. This one over here I had to multiply by 4 to make it a 12, so I had to take the top times 4. So here's what I'm adding. When you add fractions, they have to have the same denominator, and all you do is you add the top. So what's 9 plus 8? 17 over 12. Okay, now, you're not done yet.
Oh, I put 14.
That's the fastest way to add fractions. Now the problem is, you don't even know what that is actually telling you. Well, some of you might, because you remember back from Algebra 2. But this is actually telling me that I have radicals in this problem. It's just not telling me explicitly what they are. Okay, what this is, if you ever have a fraction for a power, the top number on the fraction, this is the exponent that's on the base. The top number is the exponent. The bottom number is the index number on the radical. So what you're actually doing here, what this problem actually is, it's this. It's x to the 17th power, that's your exponent on your base, and the index number is a 12th root of it. That's what it's actually telling you. And then you have to simplify it.
Oh yeah, we were supposed to know that.
Okay, but what most people have never done before is this top operation where you have to actually multiply things together. I think in Algebra 2, they probably just start you with this, and they ask you to like write what it means.
Yeah.
But they never actually tell you how to simplify it. You could do it by my method where you break up the x to the 17 in a bunch, you circle groups of 12s. I'm going to show you an easier way to do this. This is my way of doing this. I don't think they teach this in other pre-calcs. This is just something that I've learned over the years of doing it. It's the fastest way to simplify fractions. You just make them mixed numbers instead. So that 17 over 12, do you agree that's improper?
Yes.
So since it's improper, I can make it a mixed number. So 17 over 12, that's more than one full number, right? It's actually 10x It's x to the 1 and 5/12, if that makes sense. That's what 17 over 12 eats. It's one full, pan and 5 extras. That makes a total of 17. Because again, how I make a mixed number, so back to improper, is you take this number times the bottom and add the top, so it's 17 over 12. So it's one full pan plus 5 over 12 left over. And what this is, how I separate this, is here's how it works. This x can be split up into two separate x's since it is a fraction. Like that. Because those will be added together anyway. And then what you can do is the back here, I can make this a radical. This is my easiest way to do it. It is x to the 5th to the 12th root. There's an x out front and there's a 10, and that's your final answer. That's the simplified version for a fraction. You simplify it using mixed numbers. I don't think they teach it in every other class. What most classes do is they teach you to write it like this to begin with, and then just try to simplify it from there. Try to figure out how many groups of x's I can pull out by doing that simplified version, the cancellation method. I think by doing it by mixed numbers, like this, it makes it way easier to simplify radicals without having to think about it.
You should do the green one more time.
Yeah. So give me any mixed number you want. Or do you want improper?
18 13.
Okay. So let's say it's x and 18/13. We're just making this up. Okay? I don't care about the other numbers. Okay? Let's make this improper. Or let's make this a mixed number. Okay? I better turn the camera. I think the camera is in point. Okay. So how do I make 18/13 into like a mixed number? 1 and 5/13, right? So then what you do is you separate those into their own x. This x becomes a radical because it's still a fraction. The other one's a whole number, so it's just the variable up front. So this is just an x out front. The radical we have here, since the bottom number is a 13, that's your index number. The top number is the exponent on the inside. There's your answer. It's the fastest way to simplify variables without having to think about it. We could actually have done this process for simplifying radicals on anything where they put letters on the inside of a square root. Just like no matter what. So if you had something weird like this is a 6 root but you have 8 x's in here, you can change this back to a fraction like that and then simplify it using that process and you wouldn't have to think about it. Because this process would be x to the 1 and 2/6, which is 1 and 1/3. Then you simplify 2/6. And so this is x,
And then
x to the 1/3. So this will end up being x and a cubed root of x to the first.
okay, well, I see.
Okay, homework. Page 43. If you have the rest of the time to do it, you only have about 15. I was hoping to give you 20, but you get 15 minutes to kind of work on it. You guys have questions? I think I've done a lot of the problems on the board already. Next time, just say that you
You didn't do it though this time.
That's all wrong.
No, I gotta put what I'm doing.
I don't know if there's like a dash. I hope I get caught. Just don't stroll around.
I'm gonna hide the pass.
So then I gotta just go and stroll around and get my drags like, what are you doing?
Wait, where are we?
I'll give you a pass.
28. Okay.
Yep, looks good.
Hi, Graham. You're done.
Have they been actually asking for passes?
I've never had it.
They grinded this about it again.
P.3.
And in our team meeting, I'm like, and all I'm thinking in my head is like, well, all my kids keep saying,
How do you forgive yourself?
Wait out.
use the passes. We got plenty of them in the office. Every time in your classroom, you should have a pass. Because I'm asking. And I'm thinking in my head, all my kids say they've never been there.
Yeah.
That's all I'm thinking about. We literally had a 10-minute conversation in our meeting yesterday about that. And I'm like, I'm not calling them out. I stay under the radar.
Or I'm telling you, those passes are a waste
That's
of
why I
paper.
didn't
They're not
go for it.
gonna
I never did.
I love the Ninja Turtles. Quit using straws to say Ninja Turtles.
What problem are you on?
They just pull out like one of those cylinders that all the legs are big numbers together. At that point, you're okay. Hold on. End it all. Yeah. Oh.
Why not?
Right?
Go ahead.
The other day I went to get my computer, drop my computer off at the library, and then I went to Mantico's. Absolutely nobody stopped me.
I'm just gonna start bringing my own toilet paper.
Hey, I got wet wipes in my car now, just in case y'all need to take the road. So then do you turn this to 80 and then
You're having an older brother?
I need to know that. Say you know the rest.
Wait, what do you say?
We were in, no, I would.
Yeah, I would like you to start writing the passes with specifically what we asked.
Wait. 5 times 30 is 1850.
It's alright, Frank.
If we come to this, you guys are being too vulgar. I'm not letting you do it. It's gonna be like, no fractions, because you can't ask them for.
Oh, it's 3.
Yeah, he was like,
Okay, you multiply the top, and you multiply the bottom, but also you can simplify that by reducing that diagonal.
I
Only diagonal.
tapping their
It makes the answer smaller.